Hello, dear students. In this video, we are going to see what is left factoring, a context-free grammar. So, if you we know that syntax analysis is the second phase of the compiler. Hope you have checked the previous videos which I have uploaded regarding syntax analysis and how to eliminate the ambiguity and how to eliminate the left recursion. So this left factoring will be coming in the second phase of the compiler. Where will we use it is in the parsing or the syntax analysis. What is the purpose of syntax analysis or parsing? When a given input string is there, we have to check whether this input string can be derived from the given context-free grammar or not. We simply say we have to check whether the input string is following the rules mentioned in the context-free grammar or not. To check this, we have two methods. One is top-down parsing. Other one is bottom-up parsing. So top-down parsing is also called as LL parsing. So if I want to do this parsing means what? Checking. If this parsing, with the help of this LL parsing, the grammar should have some qualities. One, already we have discussed. Ambiguity should not be there. Left recursion should not be there. This two already we discussed in the previous videos. The third quality for the context-free grammar is the context-free grammar should not have left factoring. What is left factoring means? Consider we have a programming language which have if conditions. So for that, I have written a rule that is context-free grammar, right? The rules is written in the form of context-free grammar. So if you look at it, here we have a to production in a context-free grammar saying what can be a statement. So it says statement can start with if followed by expression, then statement, else statement. In the second production stage, statement can also be if, expression, then statement. So if you see in this both production, the both are starting with the same suffix. Here is also a if, here is also if. So here is also expression, here is also expression. So when an input token is coming, which is starting with if, so it will have the confusion whether should I choose this production or to choose this production, right? Next token is expression. So both the production is having expression, expr followed by if. So there is a confusion, right? So this is called left factoring. If you look at this production, this is another context-free grammar. If you look at this one, so here also, if you see, this is one production of yes, this is another production of yes, this is another production. If you look at this, it is starting with IETS. Here is also it is starting with IETS. So when a new input token is coming with IE, it has a confusion whether to choose this production or to choose this production. So this kind of confusions, which have a confusion in choosing the production. This we call it as left factors. So a context-free grammar which have this left factoring cannot be passed through with the help of top-down parsing, that is LL parsing. So we have to remove it. So to remove this left factoring, we have a rule. So here is the rule given. What is the rule given? For example, let me write it. If you have a production A, it starts from alpha, then beta 1, alpha, the production is alpha, beta 1, alpha, beta 2, alpha, beta n, and then gamma is there. We see in all this, alpha is common. So how will I rectify this? Common is called as left factoring. So how will I remove this left factoring? Write the common term alpha and introduce a new symbol, variable or a non-terminal a dash. And then write the gamma as it is, which doesn't have any common term. Now I have to define what is a dash. This a dash is the remaining thing other than alpha in this production. What are they? They are beta 1, beta 2, and beta n. So hope you can check it. Other than alpha, here it is beta 1, and here it is beta 2. Here it is beta n. So now you can understand, right? Other than alpha, these three things that I have written here. So this is how we can remove the left factoring from this production and make it ready to do the top-down parsing like LL parsing. So let us take an example and do it so that you will be clear in solving it. Okay. So here is an example. I'm going to rewrite you for to understand. So S tends to IETS, also IETS, all are capital letters followed by E, S, and A. And the next production is B. And if you look at this production, you can see this is common and this is also common. So here we have a left factoring. So we have to change it. So how will I do? S tends to write all the common terms and then introduce a new symbol. And the remaining, which is not having a common term, also written here. Now I have to say what is S dash is. S dash tends to. What is the remaining thing available after IETS? Here it is nothing. So nothing can be mentioned as epsilon. And here after the common term IETS, you have ES there. You can look at here. Here we have ES. So this ES should be written here. So I'm writing here ES. Right? And for the next production, E tends to B is there. So now this is now converted into this set of context-free grammar, which is free from the left factoring. So let us see the algorithm for this left factoring. So for each non-terminal A with two or more alternatives, with the common non-empty prefixes, common, this can be converted to this, which I have already told you. So let us take another example and we'll discuss so that you will be clear in it. So there is a production A tends to ABB, AB, CDG, CDEB, CDFB, right? So now if you look at this, you have A and A, common prefix. And here, next is also there, CD, CD, CD. Two things are having, right, as a common prefix. So solve one at a time. So let us rewrite it. A tends to, first let us take A as a common and then introduce a new non-terminal and write the remaining thing as it is. Remaining thing is this, right? It doesn't start with A. So that you have to write accordingly. CDG, CDEB, CDFB. And now I have to say what is this A dash is. So I have to say A dash tends to. So here A is taken as common. The remaining thing present there is B, capital B, or else B. Now this is the new thing. Now if you look at here, again now we have another common term as CD. Now let us solve this. So this A can be written as A dash is already there. CD is taken as common term and I'm going to introduce a new non-terminal A double dash. That's it, right? And there is one more thing. That's it. So now what I have to say what is A double dash is. By the meantime, okay, I say A double dash. What is A double dash? Other than CD, what is present other than CD? G here it is EB, here it is FB. So that is G, EB, and FB. Now that is also done. So this is now changed to here as well as here. The remaining thing, this one, you have to write as it is. So look at the order also. First one is this, the second production and the third production. Maintain that as well. Because the start symbol is very important. Here is another example. Let me discuss this as well. So let us take the next example. Next context we given is AD, A, AB, so that you will understand clearly in all situations how to remove the left factoring. So here if you see who is our common term here, the common term here is here A. So we have to rectify it. So I'm going to convert. So I'm taking all A as common and the remaining and introduce a new non-terminal and the remaining thing which is present other than A is B. Now I have to say what is A dash. So what is A dash? Here it is B. And here we after A there is nothing, right? So nothing can be represented as epsilon. And then B, then VC, and that's it. Right? Because this B is already written here. Now done. So this is now done. Now look at here again. If you look at this, you can see there another common term is present. Who is the common term now? V. Now we have to change it. So how will you change? This thing is need to change. So start symbol order doesn't change, right? First production is this itself. This itself. Now this A dash tends to B epsilon. Now the common term is B. Right? I introduce a new non-terminal A double dash. Now I have to say what is A double dash is. What is A double dash? Here when I take B as a common, nothing is there. So that is represented as epsilon. And here when I take B as a common, what is left over there? C. So this is my new context-free grammar. So now next time we won't use this all these things. Instead, this is the new context-free grammar taken. And the ordering is also first is start symbol and the, in which order we derived it. So in that order it is present. So I hope you have understood what is left factoring when we have common prefix in more than one production in the context-free grammar. It may create confusions in the parsing. To avoid that, we will be defactoring it. That is, we are removing the left factoring according to the rule. Hope you got it. If you have any doubt, just go through this video once again. You will be clear in it. Thank you, Ma. God bless you.